Magic square. A magic square is a square grid of numbers where the sum of the numbers in each row, each column, and main diagonals are equal. What it means is that you're going to have a square array, and since it is a square array, it is going to be having the same number of rows as that of the columns, right? And the number of rows as well as the columns is going to belong to the real numbers, and our n cannot be less than 3. It should be greater than or equal to what? 3. So from this illustration, it means that if our n is greater than or equal to 3, we can start with a 3 by 3 magic square. That is when our n is equal to what? 3. That is why we have 3 by 3 magic square here. And actually that's going to be the first one. From this condition, it means we do not have 1 by 1. We do not also have 2 by 2 magic square, because the n should really be greater than what? 2. Good. So having the 3 by 3 magic square, you can also talk of 4 by 4 magic square, 5 by 5, 6 by 6, 7 by 7, 8 by 8, 9 by 9, and so forth. Now, we saying that we are having the same number in each row, the same magic constant in each row, column, as well as main diagonals. This is what we mean, magic constant. Sometimes it is normally represented with M, big M, and the formula for the magic constant is n times n squared plus 1, everything over what? 2. For standard magic squares. Where standard magic squares where the numbers start from 1 to n squared, right? So it means for the standard magic squares, the numbers that we're going to fill in these square arrays, that is these spaces, right? Considering this 3 by 3 magic square, you know, it's called 3 by 3 magic square because we have you know, the rows. We have how many rows? We have 1, 2, 3 rows. That's why we have the first 3, and the second 3 we have 1, 2, 3 columns, right? We have 3 rows and 3 columns, right? That is why we call it 3 by 3 magic square. So the numbers that we use to fill these entries, that is what we're talking about, those numbers for the standardized magic squares. The numbers start from 1 to n squared, right? And the formula for calculating a magic constant for search is n into bracket n squared plus 1 bracket close all over what? N. So this magic constant, that is what we just read here, that a magic square is a square grid of numbers where the sum of the numbers in each row, each column, and main diagonals are what? Equal. So to demonstrate that, what it simply means is that, you know, this is our first row, okay, this is our first row, this is our second row, and this is our third row. And if it is indeed a magic square, the sum of each of the rows, if I find the summation of the entries in the first row, the second row, and the third row, I should get the same sum, right? And that sum is what we call a magic constant. The same thing applies to the column. If I find the sum of the first column, the second column, the third column, I should get the same number for each of the columns, and this number should be equal to the number that I had for the rows as well. And also, when we're talking of the main diagonals, we're talking of this from here to here, and then here to here. You know, because we're dealing with 3 by 3 magic squares, each of the diagonals should have 3 entries. So we have 1, 2, 3. So this one will be main diagonal. We also have 1, 2, 3. So that's also going to be what? A main diagonal. You know, this 1, 2 is a sub diagonal. Please, that's not what we're considering. You're considering the main diagonals, right? The main diagonal, the two main diagonals. And let's try to check that. Let us find the summation of probably this row, and we have 8 plus 1, that's going to give us 9. 9 plus 6, we have what? 15. And here we do have 3 plus 5, that's going to give us 8. 8 plus 7, we get what? 15. Again, we have 4 plus 9, that's going to give us 13. 13 plus 2, we're going to have what? 15, right? Let's look at the columns as well. So the first column, I have 8 plus 3, that's going to give us what? 11, right? 11 plus 4, that's 15. Again, we have 9 plus 5, 14 plus 1, we have 15. Then we also have 6 plus 7, that's going to give us 13. 13 plus 2, we have what? We have 15. And let us look at the diagonals as well. So let's consider this diagonal. So this diagonal, you're going to add 8, 5, and 2. And 8 plus 5, we're going to get 13 plus 2, which is 15. So this diagonal gives us what? 15. And this diagonal 2, we have the entry 6, 5, 4, right? And the summation of this is also going to give us 6 plus 5, 11, plus 4, that's going to give us what? 15, right? So from here, our magic constant is equal to 15, and what we are talking about has been achieved from this. And once each of the rows gave us an identical number, and this number is the same for all the columns as well as the diagonals, then we can say that we have what? A magic square. And what magic square do we have? The magic square is going to be determined by the number of rows and the columns that we do have. This one we have 3 rows, 3 columns. So this one will be called 3 by 3 magic square. So in a nutshell, you'll be given some numbers. If it is standardized, you know, magic square, the numbers are going to be ranging from what? 1 to, you know, n square, and you'll be asked to fill those numbers in the square arrays, such that the sum of the rows, the columns, and the diagonals are going to give you what? An identical value. Okay, but I want you to look at something. If we're talking of the standardized magic square, of which our first figure start from 1 as we have in S, then you're going to have 9, you're going to have 1 to 9 figures that you'll be filling the magic square with, because if you're having 3 by 3 magic square, 3 times 3 will give us what? 9. It means you'll be having 9 different entries. That is, let us count together. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So since you have 9 different entries and you're starting from 1, then you're going to what? Your figures are going to end at what? 9. Okay, that is when we're doing the standardized one. There are some circumstances that probably the figures given to you will not just be 1, 2, 3 up to 9. You can even have negative figures, right? Okay, and if you're having 4 by 4, it means you're going to have 4 by 4. That is going to give you 16. Meaning, if you're talking of the standardized one, your entries are 16. So if you're starting from 1, it's going to be 1 up to what? 16, right? Actually, I want us to see for the 3 by 3, having the starting number from 1 up to 9, we realize that our magic sum or the magic constant is 15, right? And let us use the formula that we provided here to see if, assuming that we didn't know that is going to be the sum that we're going to be having, the 15, we just want to use the formula. Is it going to be true? So let us check that. And this n, actually this the n that we have in this formula, okay, is the number of, is the type of magic square that you are having. And since we're talking of 3 by 3 magic square, 3 by 3 magic sum, 3 by 3 magic sum, let me write it to 3 by 3 magic sum. That means our n is equal to what? 3 in a formula. And according to the formula, we have n m is equal to n squared plus 1 all over 2. Okay, so our m of the 3 by 3 is going to be equal to, our n is 3, right? So we're going to have 3, then n squared, that's 3 squared, plus 1 all over what? 2. And 3 squared will give us what? 9 plus 1. 9 plus 1 all over 2. And we're going to have 3. 9 plus 1 will give us 10 all over what? 2. And 2 can go into 10 how many times? That is 5, right? 5. 3 times 5 is what? 15. So therefore, the magic constant for the 3 by 3 magic square, if you're talking of the standardized magic squares, is going to be what? 15. 15. Right. I know that by now you're asking yourself, how do I fill these numbers in the entries such that the sum of the rows, the columns, as well as the diagonals are always going to be the same as we have in this example? That is what we'll be talking about in the next video. For this one, I just want you to get a gist of what the magic squares are. And in the next video, we'll be talking of how probably you giving any numbers and a type of magic square, how you can fill the entries of that magic square. Say that you have the same, or you have a magic constant for the rows, the columns, as well as the diagonals. If you find this video interesting, subscribe to the channel.